Hello and welcome. The date is December 19th, 2025. At this very moment as we speak, a visitor from the deepest reaches of interstellar space is skimming the gravitational surface of our solar system. We are tracking the object known as 3I Atlas. It is currently reaching its absolute closest approach to Earth, passing at a distance of approximately 1.8 astronomical units. That is roughly 270 million kilometers from where you are sitting right now. This is not just another rock in the sky. This is the third confirmed interstellar object in history to penetrate our system, following Oumuamua and Borisov. But 3I Atlas is doing something the others did not. It is changing, and it is changing in ways that our current models cannot fully explain. Today, we are going to perform a deep dive into the real-time data streaming in from the world's most powerful observatories. We are going to look at the raw numbers, the spectral shifts, and the trajectory anomalies that have astronomers across the globe glued to their monitors. Because what we are seeing tonight suggests that 3I Atlas is either a very strange comet or it is something else entirely. Before we pull up the telemetry, if you want to stay ahead of this developing story as we receive updates from NASA and the ESA throughout the night, make sure you hit that subscribe button. We are tracking this live. Let's look closer at the data coming from the Gemini Observatory. Just 48 hours ago, 3I Atlas was a faint magnitude 18 smudge on the CCD sensors. We expected a standard cometary progression, a gradual brightening as it neared the Sun, followed by a predictable fade. That is not what happened. Instead, the object's luminosity spiked. It didn't just brighten, it flared. But the real mystery isn't the brightness, it's the color. As it crossed the frost line, the object displayed a distinct, vibrant blue hue. Standard cometary physics tells us this is likely due to the sublimation of carbon monoxide or ionized nitrogen. We have seen this before. But then, as it approached this 1.8 AU mark, the spectrum shifted. The blue gave way to a piercing green. Now, green comets are not unheard of. We know that diatomic carbon and cyanogen gas can glow green when bombarded by solar ultraviolet radiation. If the story ended there, we would classify this as a chemically rich but natural body. But the story does not end there. In the last 6 hours, visual data has begun to show a new, unprecedented shift. The green is being overtaken by a metallic golden tint. This contradicts what we previously thought about the chemical composition of the coma. There are very few natural processes that create a sustained golden reflection in a cometary tail. This brings us to the high-energy data. While the optical telescopes were watching the color show, the Hubble Space Telescope and the Chandra X-ray Observatory were looking at the object in the high-frequency spectrum. Comets do emit X-rays when the solar wind slams into the gas cloud surrounding the nucleus. We expected a soft, diffuse X-ray glow. What we got instead were sharp, rhythmic peaks. The X-ray emissions are pulsing. They have a structure. A NASA astronomer noted this could be the result of interaction with the solar wind, but the amplitude of the signal suggests more exotic processes. In science, exotic is often code for "we don't know what this is yet." The strength of the signal is far higher than the density of the gas cloud should allow. If the gas is thin, the X-rays should be weak. But the gas is thin, and the X-rays are blindingly intense. This implies that the interaction surface might not be a cloud of gas at all. It might be a solid, highly conductive surface. If you have a metallic body rotating in the solar wind, you could theoretically generate these sharp X-ray peaks. We are looking at an object that changed from blue to green and is now shimmering gold while pulsing with radiation. I want to pause here and ask you, is this a volatile mix of exotic ices, or are we looking at something manufactured? Let me know in the comments. Now let's layer in the thermal data. Usually a comet is a dirty snowball that heats up unevenly, creating jets of gas that cause it to tumble. We call this non-gravitational acceleration. We expected 3I Atlas to be tumbling wildly, but the light curve, the graph showing brightness over time, is remarkably smooth. It is not tumbling chaotically, it is rotating with an unnerving precision. The rotation period is locked and stable. This stability is what allows that golden glint to appear so consistent. It isn't a chaotic tumble, it's a beacon. It pulses on, off, on, off. The shift to gold has led some to speculate about surface composition. If an object travels through interstellar space for millions of years, cosmic rays usually turn it dark and red, like Oumuamua. 3I Atlas was dark on approach, but as it warmed, that crust seems to have shed. The underlying material is what is reflecting the sunlight. The albedo, or reflectivity, has skyrocketed. It is reflecting almost 80% of the light hitting it, rivaling the ice moon Enceladus. But Enceladus is cold ice. This object is hot, basking in the sun. Ice should be sublimating violently into a chaotic cloud, yet the coma of 3I Atlas remains tight, controlled, and almost aerodynamic. We haven't resolved the nucleus directly yet, but we can infer its shape. Oumuamua was elongated like a cigar. 3I Atlas appears to be different. The light curve suggests symmetry and a shape that is not a random potato-like lump. The data is hinting at something geometric. As we watch 3I Atlas drift through the constellation of Hydra, we are left with a picture that doesn't fit the puzzle. We have a comet that doesn't tumble, a gas cloud that pulses with X-rays, and a snowball that shines like polished gold. The standard model is straining. This uniqueness has reignited a controversy simmering since 2017. If nature struggles to explain 3I Atlas, another hypothesis fits with disturbing elegance: artificial origin. Harvard astrophysicist Avi Loeb has argued that interstellar objects may not all be rocks. He suggested Oumuamua might be a light sail, and with 3I Atlas, he is doubling down. Loeb has laid out 18 distinct anomalies suggesting this object is manufactured. The most striking is the trajectory. When astronomers trace its path backward, they find a spine-chilling coincidence. Its arrival vector aligns precisely with the region of the sky where the famous WOW signal originated in 1977. The WOW signal remains our strongest candidate for an extraterrestrial transmission. Loeb asks, what if the signal was a handshake and 3I Atlas is the response? The probability of a random rock falling into our system along that exact line of sight is 1 in a billion. If it's a probe, its approach could have been a scan of our planet for signs of technology. This connects to the anti-tail, a spike of material pointing directly toward the sun. While often an optical illusion, the geometry here doesn't support that. Loeb suggests it might be an exhaust plume from a propulsion system fighting solar gravity to maintain a specific orbit. Building on this, we have to talk about the destination. 3I Atlas is threading the needle of our solar system to line up a rendezvous with Jupiter in March 2026. Jupiter is a gravity well and a source of immense energy. A probe seeking to refuel or use a gravitational slingshot would aim exactly for where 3I Atlas is going. It looks like a flight plan. Furthermore, in the last 24 hours, reports have surfaced of anomalous radio bursts coming from the comet. NASA classifies them as solar noise, but independent analysts note the bursts are periodic and rhythmic. Solar noise is random. This has a beat resembling a compressed data stream. So, we have visual, trajectory, and electromagnetic anomalies. Is it simpler to invent 5 new natural theories or admit that one theory, artificial design, explains it all? This brings us to the most startling development. The James Webb Space Telescope, JWST, has been tracking its position, and the position is off. 3I Atlas is disobeying the laws of gravity. It has deviated by approximately 60,000 kilometers in a way that gravity alone cannot explain. This is non-gravitational acceleration on a dramatic scale. A rock falls where gravity tells it, a machine goes where it wants to go. The deviation occurred precisely at the point of nearest approach to Earth. This contradicts the idea of the object being passive. The vector of this deviation has a lateral component. It moved sideways relative to the Sun. Nature does away. It doesn't usually do sideways. A lateral shift implies a controlled maneuver. Speculatively, this could be a course correction following a data gathering phase. An ESA expert stated that the movement is consistent with a low-thrust, high-duration propulsion event, similar to an ion engine or a light sail. In addition to the movement, telescopes in Hawaii and Chile report that the comet flickers in ultraviolet light at regular frequencies. It resembles a modulated signal, suspiciously like binary code. The combination of the trajectory shift and the UV flickering paints a picture of an active machine. It adjusted its path, it is pulsing with energy, and it is doing all this while heading toward Jupiter. When we plug the new trajectory into a simulation, we see that the 60,000 kilometer shift wasn't an error. It was a correction to ensure the rendezvous with Jupiter is kept to the second, aligning perfectly with the plane of Jupiter's moons, including the water world Europa. The encounter in March 2026 will be the final exam. If it behaves like a rock, we will know. If it maneuvers again or adjusts its tilt to scan Europa, the debate is over. After Jupiter, 3I Atlas will begin the long trek into the dark, crossing Neptune's orbit by the 2030s and leaving our system forever by the 2040s. NASA confirms it is moving too fast to be captured, but even if it never returns, the implications are permanent. If it is a probe, it may transmit the data it collected about Earth back to its home system, potentially triggering a follow-up visit. We are no longer looking at the sky the same way. We know we live in a busy intersection. Projects like the Galileo project are now building observatories to hunt for the next visitor. 3I Atlas forced us to ask the hard questions. It forced us to consider that the gold color and the X-ray pulses were features of a technology we don't yet understand. We will be covering every new paper and theory as we approach the 2026 encounter. The object is leaving, but it has left us with a legacy, the realization that we might not be alone.